Patty, I finally understood when I asked the question where I was at return value operation. You told me I was thinking the old way of doing it when you basically did it minus SP or 4. Then when you said when it becomes a reference, my mind was on the classic way of doing yes.
There's a couple of seats over here.
Yes, I saw your Fox token or something. Yes. I guess you're a couple of your articles.
Don't be staring.
Okay. I should probably subscribe to that so I can go to the
RSS feed. I don't actually use RSS.
Okay. Okay, well, at least you see your articles, they're pretty low. Yeah, they're pretty deep. I liked it what the sentence you had about I like your support. So they're wrong. What you're talking about. I think there's a curve and somebody else is wrong. We go down.
Hello, everyone. Welcome. This, I guess, is a joint meetup of the ACCU Bay Area C++ meetup and someone else, JFrog in general as well. I run the ACCU Bay Area meetup, so these are the administrative announcements for that portion. For anyone who doesn't already know, we do this about 4 times a month at different locations across the Bay Area. Normally it's not here, but today it is. Let's see, so this is May 2nd, so it is a first Wednesday. Starting in June, our first Wednesdays will be back at Mesosphere in San Francisco, but in their new office. So we'll be back up in the financial district for the first one of June. Second Wednesdays, we do in Mountain View. So we will be right around here at Synopsys in Mountain View. Next Wednesday, May 9th, John McFarland will be talking about better numeric types in C and the CNL library for making your own integer and fixed point types. On the 16th, we will be in San Francisco at Symantec in Soma. And we'll be doing a panel discussion on what we saw and learned at C++ Now, that being a conference that's going to be happening that previous week. I'm actually flying out tomorrow to go to Colorado for that conference. So May 16th, we're going to have a bunch of people who went there and we're going to talk about what we saw. And then presumably the Wednesday after that, we'll be back in Palo Alto at A9 with our informal workshop and discussion group, where you bring things that you want to talk about. It can be from work, from play, from a book, whatever, and we talk about random C++ stuff. So that's what we've got coming up. The other announcements, I think the call for papers for CPPCon is out, and will be closing next week. So if you want to go to CPPCon in Bellevue, Washington, and talk about C++, you should submit a paper or submit a session proposal to CPPCon. And regardless of whether you want to talk, you should go. It's great. I recommend it. That is all the announcements I have. And so, unless there is anything else, Mark Galpin of JFrog.
Good evening. So 2 weeks ago, I was at the ACCU conference in Bristol. And so I have to admit, when they said they wanted me to speak at the ACCU meetup, that was a little bit intimidating, since that was a really high quality set of talks. But today isn't going to be at that level. To be honest, I'm kind of morphing between two talks right now. So you're going to kind of get a standard introduction to Konan talk that I give some places, but there's also some pieces of some new talks that I'm going to give, which I may come back and discuss at more length. Because package management has become a topic of great interest in the C++ community. And we definitely want the inputs as we're going to be discussing it. We're going to be discussing some things with the committee, and we're definitely going to want inputs from a variety of different perspectives and users as we go along. So that's kind of my disclaimer before the talk. So if it feels a little bit less than fully prepped, that's why. Also, my demo hates me. I'm going to blame the fact that my demo requires that it be in Groovy. And of course, we know we can't trust those Java guys. But we'll move on from there. So who am I? My name is Mark Galpin. I am the product manager for Konan. I only recently became the product manager for Konan at the beginning of the year. And so when I left my previous team, the solution engineering team at JFrog, this was the gift they gave me. Because I lost a bet, I decided that I would use it on all social media related to my new job for a while. So that's me. Basically, just to be clear, as product manager of Konan, it's my privilege to lead the complaints department, basically. I'm not, sort of one of the originators of Konan. That's a team in Madrid that JFrog acquired a couple years ago. But I work closely with them, and we're working to, evolve the product. It went 1.0 right before I joined the team. And so now we're working on, evolving this product now that it's a full GA 1.0 product. And if you want to try out Konan through the course of this, and I'm going to, talk a little bit about it today, but if you want to try it out, I just want to make clear that I am open at any time to talk to anybody who has ever used Konan about what they think about it. We have a Slack channel you can ping me on, but also if you're here in the Bay Area, you can come here, I can go to you. Product managers love to talk to customers, and one of the upsides and downsides of an open source community is that sometimes you have to go looking for your customers a little bit harder to find it and actually get to talk to them face to face than you do when when they have to pay you money so you know what their address is. So please do reach out. I really want to hear from you. A couple things about JFrog. So first of all, this is not here, as you may have noticed. But this beautiful view can be yours. The banners surrounding me might have something to do with that. This is indeed a view of Napa. So we'll talk more about that at the end. But if you've ever wanted to go to Napa and you want to talk about C++ while you're in Napa, drinking wine, Swamp Up is a great way to do that. And I strongly encourage it. JFrog itself is always hiring. Not so much on the C++ stuff, but you know, we're always interested in solid engineers and solid pretty much anything else's. So there's people here in the back. Hey, Lorena, who will be happy to talk to you if you have any interest in working here. In general, JFrog is about managing binaries. And you know, we're probably best known for our product, JFrog Artifactory, which is a universal binary manager. Odds are that somebody inside your company, if you work at a company of any size, and probably even if you don't, is using Artifactory somewhere. We have pretty reasonable market penetration. I can talk at length about how much I love Artifactory because that was what I did for 3 years before I became product manager of Conant. But today we're here to talk about C++ package management. So, quick agenda, a problem statement. It's not the only problem statement associated with C++ package management, but it's one of the most popular ones. I want to build C++ faster. Why should we do package management at all? And specifically, why do it with Konan? And then talk a little bit about CI/CD. Now, this why section is the part I told you that I've kind of been significantly playing with and expanding. So we'll see how some of my new slides go. We'll see how some of the new slides go. And of course, there's ample time for Q&A at the end. But additionally, if I'm going through things and you really want to ask a question, this is a small group. So by all means, feel free to ask questions along the way. If I do seem to ignore you, it's because I don't feel like it's a good time to stop the flow. And I'll get back to you, or you can ask at the end. But for the most part, I'm pretty open to interruptions throughout the talk today. So, C++ development. So first of all, actually, before I get started, how many of you know Kona? A couple of you. Have any of you used Konan at work? Okay. So good. So this is a pretty introductory talk to Konan. And I'm glad. I was a little bit scared that, you know, I'd be going to a room and everybody would be like, oh yeah, I use it in production. And then you'd all know more about it than I do. And that would be very embarrassing for a product manager. But excellent. So as C++ developers, we work on really cool stuff. And in fact, you know, nowhere better than Silicon Valley to talk about all of the awesome things that are happening in the C++ world today. We have automated cars. We have so much of IoT device work is at the heart of it in C++. Some of the biggest stuff of a lot of AI has some C++ in it, if it's not even majority C++. Some of the biggest things that are happening today in the world of software engineering still, I tell some people, have C++. You know, our CEO a couple of years ago before we started brought in Conan, he's like, so does anybody actually still use C++? And I'm like, yeah, you know, actually more than half the world's code is still written in C++. And, you know, some of the coolest stuff that's being developed, some of the most cutting edge stuff is still done in C++ because fundamentally speaking, it's a really good language and some things you just have to get that low level. So on the one hand, as a C++ developer, we're on the cutting edge of some of the coolest bleeding edge technologies in the world today. On the other hand, our toolings often feel like this. Now, don't get me wrong, Frogger is a great game. And, you know, it has many generations. I can play it on my Fire TV right now. It's been out for as long as I've been alive. You know, and it's been rebuilt for pretty much every platform since I was born that you could play a video game on. So there's nothing wrong with Frogger. It works. People enjoy it. But it doesn't actually feel like, you know, the sort of system that you should be building an automated car on. And, you know, this is true of a lot of the tooling around C++. And especially developers who get to work in other languages as well as C++. And I've met several of them. You know, they go and they get to go and play in some modern language or like Python or something, and they see all these CI/CD tools. They go back to C++, and you know, they wonder, well, can we do better? Or is it just that all of this stuff is just extra garbage on top that you know, we don't need because we're C developers? So it's all about accelerating code, right? We know that the days when we could code a different way and speed up our coding processes are over. We already know how to do Agile. We already know how to do code reuse. You know, there's not, from a pure aspect of programming, right? There's not much you can do to accelerate the curve. There is, as Fred Brooks said quite some time ago now, no silver bullet. But on the build and integration side, there seems to be more happening. And if we go out and we look throughout the world, we have this revolution called DevOps that's happening. And we have package management. And you know, this change in build and integration processes is again allowing us to accelerate software development in ways quite outside of what you might call programming practices or how you run a team of software developers. And so Konan aimed to bring some of that experience, some of those advantages of package management to the C++ world. So why would we want to do this? So the first reason is build it once, use it many times. Building takes time. In fact, I mentioned at the beginning that my demo hates me. And one of the problems I had in fixing it is that the part of the demo that was hating me was caching my pre-built binaries because of a string conversion issue in Groovy for reasons I don't quite understand, but we'll get to that on another day. Groovy being Jenkins's language, not for any other reason. And, you know, it takes about 10 minutes to build Boost on my build system. And I realized this as I was struggling with this demo, right? That, you know, I hit build, and of course, you know, the thing that's failing is the last step. So it goes along and it builds and it builds and it builds, and I hit build and I go get a slice of pizza. I eat a slice of pizza, and then my build fails. And this is pretty painful, and it slows down your velocity. I could be spending that 10 minutes doing testing. I could be spending that 10 minutes doing lots of other things with my life. And there's no real reason to have to keep rebuilding Boost. That's in fact why I picked it, is because, you know, it's a pain in the ass to build. But once you've built it, you don't really need to keep rebuilding it. And, you know, that's 10 minutes of my life I want back. The other thing, of course, is every time I go to recompile something, I introduce a small but real element of risk. Maybe I set the wrong compiler flag. Maybe I failed to set an optimization that for this particular library is very, very important in having its runtime built in a performant way. Maybe, you know, maybe I'm going to introduce some sort of namespacing error because I was really stupid and linked the same thing twice in such a way that the linker didn't catch it. It's relatively hard to do these days, but I can actually remember times when it was easier. You know, there's lots of things that happen when you go to recompile. And the reality is that every time I recompile, I have a chance of doing something wrong. And if I don't have to recompile, especially code that's already been tested, if I don't have to recompile it, I not only save the time of not having to recompile it, but I know for a fact that it hasn't changed. So these are all things that have been known for years. And if you're like me and have been coding for quite some time, you probably remember CVS or Subversion repos that you know, had a very simple solution to this problem. You just had a whole bunch of .lib files checked into your Subversion repo. How many people have had this experience? Now, I have a question for everybody who says that they've had a .lib file checked into a Subversion repo. When you were first introduced to source control, were you, like me, told, don't put binaries in source control? And I'm seeing everybody kind of nodding their heads here. And yet, you know, if you used the old generation source control systems, I'd be willing to guarantee that all of you had binaries checked into your source control to solve these problems. And if you're talking about Subversion or CVS or most of those ones, it wasn't a big deal. It was annoying and it caused problems for the people maintaining the source repo. But the reality was that it didn't really cause serious problems. There was partial checkouts. There were lots of techniques to avoid having to pull those binaries down every time you run it. And then Linus did the world a favor and invented Git. And Git is awesome for all of the things related to code. Absolutely amazing. But checking binaries into Git is a really, really bad idea. Especially if those binaries are ever going to change. If they're never going to change, it doesn't really matter very much because you have to download them somehow, and you know, and they'll only show up once. But it's the nature of a Git repo; it doesn't throw things out, which means that if those binaries ever change, you have to clone not just today's binaries, but all the old ones too, potentially. And that's not fun. And in fact, because some Git repos also require that they be able to pull the full clone into RAM before they will send you the object, I have also bricked a Git repo by checking a binary too large into it that it couldn't then load into memory in order to calculate the clone and send it to me. Yeah, that was a funny day. I was actually testing Git LFS when I did that. And I just misconfigured Git LFS and checked the binary in instead of through LFS, and that was the end of that. So we've said for decades, don't store binaries in source control. But now that we're starting to use Git, we really mean it. Please don't store your binaries in source control. It causes problems. So, but if the binaries aren't with source control, then somehow you have to manage that. And it's not easy to do. You know, projects are large. You know, I was watching a talk by Google the other day, and he was talking about some of the early days of Google, and he said, oh yeah, and we had a really large code base of 1 million lines of code, and of course everybody cracks up laughing. because, you know, a million lines of code isn't all that big anymore. But a million lines of code in and of itself is actually large enough to really be a pain in the ass. And, you know, I certainly remember when I was build manager of something that was a mere 2.5 million lines of code, that was my night. You know, everybody would go home at 5, I would kick off the build. And if the build went well, I went home at 8:30, 9 o'clock. And if the build didn't go well, well, hopefully I got home before I was expected to be in the next morning with the pre-built binaries, just to give to the test team. So, you know, projects, especially legacy projects in C++, are some of the larger ones out there. The builds are slow as a general rule. And dependency management is not trivial, because not only do you have the standard problems of dependency management, transitive dependencies, diamond dependency graphs, you know, how do I track my binaries? Where do I store my binaries? You also have to worry about API compatibility. And this problem is what makes C++ different from, say, Java, which has had package management for more than a decade now. You know, so why did Java get it first? Well, Java got it first because a Java jar works everywhere because it has the JVM. And in C++, the binary I build may not work on your machine. Or it may not work with your compiler. And modeling this is, in fact, the thing that makes C++ package management different, if you want to do it at the binary level, than any other approach to package management that you have to do. And it was to solve these problems that Konan was created. So what is Konan? So first of all, Konan is cross-platform. It's based on Python. To help make it cross-platform, we had to pick some sort of DSL for expressing Konan packages. Python is one that, you know, we found most C++ people were already using in their production environments for one reason or another anyways. But beyond that, one of the key points about Konan is that its package management has to model and function on any package that C++ works on, any platform. ARM, Windows, Mac, Linux, all the very, very many flavors of Linux, Unix, VAX, Solaris. I have seen Konan packaged on all of these. It's open source. So package managers basically have to be open source. It would be stupid to use anything that low down in the chain that wasn't. And Konan is under the MIT license. It can't be too centralized because at the end of the day, people don't really want to have to just suddenly trust mysterious binaries coming from afar to suddenly start working. There's a lot of places where that just doesn't fly, and that's okay. So it has to both handle the binary, but also one of the big advantages that people get out of package management is easier consumption of open source, right? It's no longer a matter, I want to bring in an open source library. The first thing I have to do is how to figure out how to make it build in my environment, right? This is one of the great annoyances of bringing in open source in C++ versus bringing in an open source in Java, where all I have to do is, you know, declare it in my POM file and it's there and it works and I've got the library. So I want to be able to handle binaries, but I also want to be able to build from source in such a way that no matter what my platform is, the system just knows how to build it. With no matter what compiler I have, what build tool I'm using, whatever. If I'm going to have binaries, I need to model API compatibility. There's just no way around that. And that's Konan. Architecturally, we have a client which sits on a developer or CI machine. And then in most collaboration environments, you have a server of some sort. The server might be Conant Center on JFrog bin tray, which is sort of a central repository of open source Konan packages that we're starting to build. It might be the little MIT licensed Conan server that we use as a reference implementation of our server. It might be Artifactory. There's a free version of JFrog Artifactory for C++. So let's talk quickly about Conant Center, because some of you probably work on open source libraries, and I want to get the word out. So Conant Center is a place where we host Konan packages for open source C++ libraries. It's just a list and downloads for open source stuff. It's freely available to everybody. We require that the libraries be open source to get into it. We have some of the major OSS libraries already there, but we've only been at it a fairly short while, so we still have a long ways to go. Conant Center itself, you see it's the little baby frog on top of the bigger frog. It only has about 50 packages right now. Throughout the open source community, there's about 500 prepackaged OSS libraries available for Konan. We haven't gotten them all accepted into Conant Center yet, simply because we're really trying to work with everybody to make sure that the cross-platform build recipes really work on pretty much every single platform. For the first set of libraries, we'll probably be a lot less strict about that after we hit 100 packages. But for the first 100 packages, we really wanted to be, have 100 packages that were, really good examples that the rest of the community could use before we put them on Conant Center. And the point is, we have both the pre-built binaries for most of the major platforms and the recipes, which, like I said, should work on pretty much any platform you can imagine to build on. JFrog Artifactory Community Edition, on the other hand, is for your local scenario. Many people, for any number of reasons, do not want their build system to go out to the internet and download a binary and just randomly insert it into their build. So Artifactory Community Edition is free as in beer. And it supports Konan. It also has a generic binary capability. So you can do, your executables, your zip files, your tar files, whatever else you may be doing through the course of your build that you need to store somewhere. And there's no limitations on use. Please go out, have fun, use it at work. We know you'll like it, and eventually you'll decide to pay for something nicer. It scales well, but it doesn't scale, to 100,000 developers by itself. So that's those two things. Let's talk a little bit about the anatomy of a Conan package and what goes on the server. So I've kind of hinted at this, that a Conan package is what we call a recipe. And a recipe basically tells the client two pieces of information. One, how do I build this library? And two, if I have this library pre-built, what do I have to do with it? And three pieces of information. And three, what other packages do I need in order to build this library, or in order to use this library once it's been built? So the first part is the recipe. And then the second part is what we call the package binaries, which are the pre-built binaries that go with it. And there may be 2 of these, there may be 1,000 of them, depending on how many different platforms somebody has bothered to upload pre-built binaries for this package to your local server that you may have. The largest I'm aware of on Conant Center is OpenSSL, which has, I believe, 500 different platforms and binary compatibilities it's been built for at this point. Now, granted, that includes release and debug and all the different architectures, et cetera, but it's a pretty impressive set. And the idea is that when the client requests a package, it requests the recipe, and then it requests the particular package binary that it needs for its build. And the way it figures that out is there's a concept of a profile for each binary that has all of the basic information about the binary compatibility information. Is it a shared or static library? What architecture was it? What build type is it? What compiler was it built with? What version of that compiler was it built with? What OS is it built for? What version of the libc++ standard library is it using? And a couple of other switches that are known to impact ABI. And basically what we do is we take this profile and we hash it. And so then you pull, and we have normalization, of course, to make sure that the hashes match between two uses. And then you pull the package binary you want based on the hash of the profile that you've had configured. And so far, our users have found that this models pretty much all scenarios of binary compatibility that we've run into. We have a couple of edge cases that we're looking to add to the model, which mostly have to do with compiler flags that don't work on some platforms and do on others, and making sure that it fully understands how that works. So let's show you what it looks like. So I wanted to start with the simplest use case for Konan. And that is, I want to build an application and I want to consume open source libraries that already exist, or internal libraries that somebody else has done the hard part of packaging for me. And for that, all I need is a Conan file.txt. And in my Conan file.txt, I can see here that I have a requires section where I declare a pair of dependencies, boost 167, poco 190. I declare my generator is CMake. And optionally, I let the system know that I'm not looking to use shared libraries for either boost or poco. And then I do Konan install dot. And off it goes. And it's downloading the recipes. Now you may notice that it picked up a whole bunch more than just boost and poco, because poco in turn requires OpenSSL, which in turn requires bzip2. And bzip2 in turn requires zlib, if I remember the chain correctly. And we got on here, we downloaded all the binaries, and now I can build. And that was a lot quicker than if I had to compile boost. Oh, wait a minute, I haven't finished the build yet, sorry. I keep forgetting that CMake is a 2-pass build. I was a C developer, but I have to admit that I have, as I've been doing product management type stuff for a while now, and so we didn't use CMake when I was writing C. And I have now built my super complex timer that just nicely calls me back whenever it's building. Is this big enough for people to see, by the way? Sorry. And that was all it took with that fairly complex dependency tree. And that's kind of the point on getting started. You know, if you have, you know, especially if you're doing, you know, a greenfield project and you just want to start playing and you want to use some popular open source libraries, probably the most popular open source libraries may already be packaged for you, and you can just go. Now, I get asked, what does it look like if I have to create my own? So all I have to do, this one I've run the demo before, but pretend that I did not. That is not supposed to be open. Pretend I did not, and you wouldn't see a Conant file.py there. And so I just do Konan new, hello, 1.0. A Konan coordinate has 4 pieces. It has a package name. It has a package version. It has a organization name. And it has what we call a channel. So basically you say the package and you list something about its provenance. And the provenance usually relates to who created the recipe, the Konan recipe, not necessarily who created the package. And user and channel can be used for lots of different things. A classic example, of course, is the GitHub repo in the branch that the recipe is built from. You typically tend to see channels names, things like testing, stable, master, stuff like that. It turns out that these dimensions aren't quite meeting everybody's needs. We're probably going to roll out some additional dimensions shortly because the dimensionality gets a little bit complex when you have recipes for somebody else's library, which is a quite common use case. But it works pretty well. So I hit Konan new, and it goes out and it creates for me basically a starting template. So it creates a Konan file.python. It creates a templated CMake lists for me. It creates a CPP file, a .h file, and it even goes and creates a test package for me to fill out later. Now, of course, if you don't need all of these things, generally speaking, a lot of this code already exists, and you can just modify it. A Konan file looks a little bit like this. So basically, it has the name, the version, some basic metadata. You know, if it's an open source package, what is its license? What is a good URL for it so people can go out and look on it on GitHub? Descriptions. Names of some critical settings that it tracks when it builds that may impact what it does when it builds. What generators it supports out of the box. Since my default generator is CMake, this one was built for CMake out of the box. And then it just has some basic stuff, and it's saying, okay, this package owns all .h files and all the standard extensions for C++ binaries. And take those and package them up when you find them. This can get a lot more complex, obviously. If you've got a more complex source tree, you may want to start telling it, you know, go look in some different places, or maybe you have more defined things. But this basic Konan create works for a lot of very simple libraries. you know, if you're building up your typical SDK, you may indeed be able to get away with this sort of thing for its component libraries. And then if I want to create a package, I just do a Conan create dot. That will go out, it builds my package, and it even runs the test on my package before it creates the package. This is now available locally. And if I want, I can then share it with other people by I can share it with other people by adding it into adding my server. You don't really need to see me upload a binary. So since I forgot to reconfigure it, I'm going to skip that step for the demo for right now. I got a brand new VM to do my demo on 45 minutes before the start of this talk. So.
Python script generating the CMake files?
Yes and no. So here, it's a good question. It's a good question. So here's my CMake list. So this one did generate the CMake file. And in reality, all it basically does is it tells me to include this Konan build info.cmake and to call this Konan basic setup helper function that we make available. And so if you had a standard CMake option, you would have your standard CMake and you would just add these lines up to the top of it. Yes.
How do you handle the fact that many libraries have loads of different dash-defined configurations? So, for instance, OpenSSL, I don't want the bits in it that I can't export or something like that.
Yeah. So a lot of this is handled in the recipe. And so when you're creating a Konan recipe, you have to figure out, like, well, how do I handle the different defines for this package? And that's part of, why building a recipe for a C++ library is a bit of a pain, right? Is you have to say, okay, if I'm in these environments, these defines are going to be. Now, the good news is that increasingly, those defines, libraries are starting to use mostly just the compiler native defines for most of their work. And this carefully, sets up all of the ABI switches in the compiler and all the optimization switches in the compiler. And then beyond that, if you want to add additional ones, you can add additional compiler switches in. And there's ways to indicate whether or not that impacts ABI compatibility.
So as long as they're exposed on the recipes, they can be pulled in as correct dependencies. And
yes.
Then way up or down the tree, depending on your point of view, you can find the right binary version that satisfies everything.
That's the theory. I feel obliged to point out that Konan is not magic. And I don't think you're expecting it to be magic. If you're smart enough to ask a question like that, you're hopefully not expecting it to be magic. But satisfying dependency tree constraints is more complex in C++, and it will find it if such a thing exists, it will find it. And critically, if such a thing exists and it doesn't have a copy, it knows how to build it. Yes.
So the question is, how do you, first of all, how do you compare Konan to, like, there are other attempts, like chocolate cake, like PC, whatever. So how do you compare those?
It's a good question. So to my knowledge, and just as a disclaimer here, doing a more detailed analysis to answer that exact question is actually on my to-do list for next month. if I am misstating the capabilities of another package manager, please come and talk to me afterwards, and I want to get that information. But my understanding of most of the other competing capabilities is that they work for fairly basic cases and fairly simple dependency trees. Where Konan really comes in is really being able to model ABI completely. Really being able to handle some of the weird things that happen in stuff like the OpenSSL library, that happen in some of the weirder ways you can decide to compile boost. What I hear from people who use it is that the reason they use Konan, which is in some ways a little bit more difficult to use than some of the other package managers, is because it is genuinely 100% cross-platform, and it genuinely covers basically all of the edge cases of build environments, so that it really meets all the scenarios. And as I said, I don't want to try to get too deep into point-by-point comparison, because I haven't done the research yet to give that yet. Yes.
When I worked on C++ in the past, one pain point for ABI compatibility that I encountered is signatures and functions have changed or members of a struct have changed because due to a mismerge, things get reordered unintentionally. So we can tool track that level of API compatibility with the previous year library that we were building.
So in this sense, we handle it in a very simple way. And that is that we assume that even the most minor versions of libraries are typically not ABI compatible. Now you can change that assumption. You can build in an assumption if you want to make assumptions based on semver. You can, in a recipe, you can actually declare that, if you have the first 2 points correct, then patch builds are always ABI compatible. But sort of the default out of the box assumption that comes with Konan is that 2 versions of a library are never ABI compatible. Now they may work together, right? But you should only have 1 version of a library in your dependency tree. And to be honest, if you don't do that, you also run into risks with ODR and some other things like that as well. So, you generally, deal with it. But it's a genuine risk that you take. But, and this is why a lot of people are very hesitant to declare Konan dependencies with version ranges. You notice that when I gave my consumption example, I had fully declared versions. Konan does support version ranges. But honestly, I don't see them used much in the wild. It's something I would like to change as the package manager matures, as recipe building matures. I would like to see people use things like latest, at least in development, more often. So you're not pinning versions and that sort of thing. Konan does make assumptions that says that if it's rebuilding, it can pick, patch versions of libraries as it pleases, for example. When a library's version string matches semver, it doesn't just, not all version strings do match semver, in which case Konan may or may not know what to do with it, again, depending on whether the recipe gives it some more detailed information. It's not a perfectly solved problem. We just think that we've managed to solve it better than anybody else has, which is, not necessarily a super high bar to cross. Yes.
When I build my application with Konan and pull in the library dependencies, what's then the story on distributing my binary, giving it to someone so that they can use those same dependencies?
Yeah. So that's kind of where the upload to a server comes in, right? So if you're building an open source package, you can upload it, to Bintray, make it available, apply for it to be added to Conant Center. whatever. If you're doing your company's proprietary libraries, you have an Artifactory CE on premises sitting on a server somewhere. It responds to nice web protocol stuff. You upload it there, and then everybody can get it down through Konan, and you have your Konan remote list, right? So this one comes with the Conant Center, you know, out of the box, and you can add your local remote that's that Artifactory CE, where you're sharing your company's binaries at the server of your choice.
I can run my own repository if I don't want to try to build this process.
Absolutely. So, you know, it's local to your disk anyways. Right. So right now, if I do a Conant search, you know, you'll see a fairly limited list of binaries. This Conant search, absent a command to search a specific location, is searching my local cache. And my local cache is just in there, my total/.conant directory.
So we're going to build out the library that's pre-built for me. It's proprietary. I don't build it, which like use a readelf to inspect the library versions. That it's built with. Take the recipe that just copies that library and access those configurations. Absolutely.
And this is actually a fairly common use case of Konan in corporate environments, is to just do that packaging. Yes.
What happens if the network is off?
So define the network is off.
I'm on a plane.
So that's why you have your local cache.
So it will look in the cache, and if the cache satisfies the requirements, it'll go ahead and do that. Exactly. Even if I'm creating a new project.
Even if you're creating a new project, if you have what you need, it has no network dependency. It's happy with that. And in fact, it was very important to us, and we're constantly working on improving this flow, because the reality is this is the flow the developers use, right? Whether they're on a plane or not,
or the ski slopes.
Whether you're on a plane or not, right? You really don't want to keep going to some server to have to hit things all the time when you're building, because that's always going to be slower than stuff cache your local disk. A lot of actually what we've been doing in the last couple of months has actually been smoothing out some of the flows around how do I update a package in my local cache when I don't want to upload it to the server yet because I'm working on it, and things like that. That's actually been something that we've been working on since 1.0 to just kind of make the experience of building a package for the first time better while we're doing it. Yes.
So in the Konan package, you mentioned the headers, and in your example, the CMake files are packaged as well, the binary?
Yes.
So for instance, let's say that boost was built with CMake. Am I tied to CMake, or can I, like, say, export to Bazel, let's say?
So you're not tied to CMake, but you are, based on ABI, tied to the compiler, right? But you're only tied to the extent that ABI ties you.
So it could like generate for Bazel, for instance?
I don't know that we have a generator for Bazel, but you could build one. I don't think we have anything out of the box that directly supports Bazel at the moment. But one of the cool things about Konan, and one of the reasons why we wrote it in Python, is to make it easy to extend for any build system. And yes, it could easily be done. Yes.
Does it integrate with Xcode?
I believe the answer to that question is yes, but I don't know for sure. Yes.
To continue on that question with Xcode, basically. So I see two use cases for a package manager. One, if I want to take a library or application to compile it, that's a perfect use case. I spent a week compiling this right a couple of weeks ago, or less, because it's complex to do. More than complex. And I understand and I press a couple of buttons and download a gigabyte of sources and do everything basically. So now another thing is I want to integrate. I am writing my own application. I want to integrate that library into my own environment. Meaning that I want, for instance, I want to build the Windows application using CMake. And good luck getting CMake to Windows. It's not as easy. So I want it in that sense. I want completion. I want all the native configurations. So how far is, of course, I don't expect you to solve it, but how far you go in trying to solve it?
It depends on the recipe. For the most part, we give you the headers, we give you the libs, and we expect your IDE to deal with the rest. If you want to include, if you're building your own packages and you want to include some IDE specific files to go with it, you can do that. We also include typically a source tarball. Unless it's a closed source package, then it obviously doesn't have a source tarball. Nothing on Conant Center is closed source, but we support that use case. Most things that are open source provide the source tarball that they were built from.
And symbol tables?
If you package them, yes. So yes, typically in a Windows build, the PDBs are packaged in the debug build. Yeah, I mean, a lot of the challenges, OpenSSL has different dependencies in Windows than it does in Unix systems. I believe because, if I remember correctly, they use something other than zlib in Windows because they don't want to try to make zlib compile in Windows. I think that's different. I haven't compiled it on Windows in a while. And these things, if you're in that scenario, you kind of have to manage a little bit of that at the recipe level, right? You have to, as I said, Konan isn't magic, right? The person building the recipe does have to understand how to build the project and be able to explain to Konan, this is how you build the project. This is what you need to know to build the project. It's not a build system, right? Konan uses another build system. It uses MS Build, it uses CMake, it uses Make, whatever. But you have to be able to explain in the recipe, how to use some selection of build systems and make it work on a given platform. And if there's a platform specific rule, and there often is for some platforms, then that does have to be included in the recipe.
Are recipes extensible?
Recipes are 100% extensible. They're just Python.
Can I include a general recipe or a recipe that's public included in my own customization?
So this is something that we actually discuss a lot in the community. The answer to that question is yes, but then you have to have, basically you have to have the old recipe as a separate Konan package.
Recipe itself? Or?
If you want to have one Konan file include another, then you have to have the other Konan file be a dependency of the system, be a build dependency of the system. We have what we call a build requires section that says, in order to build this, you first have to build these things, right? And if you are going to have some sort of Python that you have to import in order for your system to build, then you have to have that imported Python be a build requires, because the Konan file itself assumes that it's the root project and that it owns everything. And if it doesn't, you have to give it special instructions basically on how to handle that scenario. But at the end of the day, it's Python. And as long as you're reasonably careful, you can tell it to do all sorts of crazy stuff. I don't recommend it, but you can. So I think at some level, I guess the good news is that you seem pretty interested in it. And I wanted to talk just very briefly, but I'm only really going to touch on these topics. And I hope to come back later in the year to talk about them. And the reason I'm touching on these is that if you are interested in these topics, I would like to talk to you. Whenever you have time, maybe open email correspondence, whatever. So the question is binary management even a good idea? And there are certainly people, people I respect in the C++ community who say the answer to this question is no. I disagree with them, obviously, or I wouldn't be working on Konan. And I disagree with them for a couple of different reasons. One is just this sheer build speed issue. If you're a small startup in Mountain View whose name begins with G, you may have infinite computing power for your compiles. Most of the rest of the world does not. And compile time is a major concern that they have. We could have lengthy arguments as to whether or not it should be. And we could even agree that it probably should not be, as long as we also agree that it actually is. You know, there's no question that versioning is a complex topic and that semver doesn't really cut it for large projects. Which doesn't mean that versioning is intrinsically a bad idea. It just means that we shouldn't be thinking about versioning as a really as a user-facing concept. And I had to bring up this slide. I'm glad you guys are privileged to get some of the very last SpiderFrog t-shirts because we go with a new t-shirt every year. And you know, the point is, these are different Spider-Men. Especially the last one, very different from the ones before it. And on the one hand, if you're going to the latest Spider-Man movie, sort of by definition, you don't care too much about the previous Spider-Man. Because if you do, you're going to be disappointed. But on the other hand, you know, if you go to a previous generation Spider-Man movie or read a previous generation Spider-Man comic, it helps to know that there are in fact different generations of Spider-Man and that there's reasons for that. So versioning, even if we set aside the supposed benefits of semver, and I am willing to do so because I acknowledge that semver has flaws, although it also has advantages as well. And where you can use it, it's nice. Versioning still allows me to do a lot of different things. It allows me to manage automation and to know, it allows me traceability. And traceability isn't just a matter of, first of all, knowing where something came from. It's also being able to talk about it, right? A Git hash is a very obnoxious thing to have to communicate to somebody about. So what version of that library are you using? I'm using 33E, FFABCDE, whatever. I've actually had to do that over the phone. It wasn't a good day. On the other hand, of course, sometimes you run into the opposite problem where people don't correctly advance version numbers. I just call those people evil. I had the lovely experience before I joined JFrog. I was a contractor for the United States Army, and I was out doing a brigade level field exercise and had provisioned some 12 different mobile server systems with a piece of software. Finally ran a test on one of them, and it failed. And I called the guy up and I said, "You swore to me that you fixed this bug. And we tested it in the lab right before I flew down here." And he said, "I did. It works." I say, "Well, I've got the CD and it doesn't work." He says, "But we shipped you the CD." And I read the label off the CD. He says, "Yeah, that's the CD I shipped you." Turned out I had 2 CDs with the same label and different versions of the software. Because CM had decided that since it was an emergency patch, they didn't want to issue a new version number. And of course, I had just spent a week installing 12 mobile server systems, and I didn't know which ones I had installed which CD on. I spent the next 4 hours trying to figure out what file I could manage to checksum so I could figure out which version I'd installed, because I really didn't want to have to reinstall all 12. That ranks up there as probably the worst configuration management nightmare I've ever experienced. So I trot it out occasionally. Communication matters. Another thing that actually isn't talked about a lot when it comes to versioning of things is knowing when you can throw stuff away. One of the problems with, if you do want to do, so one of the approaches that people sometimes say is, okay, well, I'm going to manage all of my versions basically based on source control, right? And I'm just going to build all the time. And of course, I'll do caching of the builds and I'll store them. And, we'll just keep storing cache binaries as we need to. And so then the question is, well, when can I throw a cache binary away? And there are ways to solve this problem. I'm not pretending that there's not. But one of the easier ways to solve this problem is if you actually know how old it is, how often it's being used, and things like that. And versioning helps with that. Now, that said, the JFrog vision is liquid software. And when we talk about liquid software, we mean that the idea is that one version should flow to the next so smoothly that nothing but an automation system needs to know what the version is. So I'm not trying to say that versions are something that need to go to a change control board, that versioning is something that we need to lock down. As I said, I want people to get in the habit of using version ranges. And if your build breaks because you're using a version range and you're pulling in a new version of the binary that doesn't work, by all means, in many scenarios, the correct thing to do is to fix based on the new version of the library. Not always. Sometimes that's just not a practical solution. But when it is, it's actually probably a better practice. The other reason all of this matters, oops, I didn't change the title of this image, is promotion. I want to have a dev image, a prod image, etc. I want to be able to move it. And as I said, I would much prefer to do this with binary than source code because I've got that traceability. When something goes wrong is when traceability matters. When 50 years from now, somebody wants to look up your COBOL program and they want to try, and they find a bug because they are, let's say, to take an example from early in my career, they have realized that many COBOL programs that were written 50 years ago only used 2 digits to describe a year, and that suddenly a new century was coming. And so suddenly you have bugs in software that is literally, has been running fine for a decade or more. What do you do about it? This is where having good traceability really matters. Is this actually the binary I think it was? Now, if it's really 20 years, good luck. But if it's only 5 years, you're probably still at the point, who here has tried to build code that they checked out of source, that was checked into source code 5 years ago? And how many of you succeeded on the first try? Congratulations. Most people aren't good enough about putting enough information in that you actually can just check something out from source control from 5 years ago, install it on your environment, and have it suddenly build. Okay, some people are more careful than others. And mostly the only people who are people that intentionally work for that. And I told you, I was an Army contractor. The Army, in theory, did. We were hiring people like General Dynamics, and they were supposed to be building things that we could build 10 years later. And it could be done, but usually not on the first try. There was always something. There was always one piece of build configuration that somebody forgot to check in or somebody forgot to write in the README because it was just assumed. So, yeah. So I have. So that's all we've done so far. This is where CI/CD comes in. And I'm going to skip ahead because I don't think most of you need to be told why you should do CI. Let's just take it as a given that you should. Konan is super useful because you can combine it with this ability to share binaries, cut down your CI build times. Effectively speaking, build time in CI, build plus test time constitutes your overall velocity in some level. There's shortcuts you can take to get around this, but CI builds take time. The less time it is, the faster you're moving. And generally speaking, if I'm gonna spend time in CI, I want that time to be spent on more advanced and complex tests, not on compilation. And if I can avoid recompiling libraries, that just, that's 10 minutes of my life, 20 minutes of my life, 30 minutes of my life that I can get back. And most of the time, honestly, you don't give it back to the developer, you give it to test. And you let automated tests do more in CI. You handle a couple more automated test cases. I know for Artifactory, we're constantly having wars between the dev team and the test team of, I need the build to be under 45 minutes. And I need to test these other 100 edge cases that customers have managed to find that can break our system under certain scenarios and make sure you didn't cause a regression. And of course, there's levels of tests. This is what a promotion pipeline is for, et cetera, et cetera, et cetera. But the more tests I can run in that first build, in that smoke test build, the happier everybody is. It really sucks when the last test you run is the one that fails. That's just a really bad day, especially if it takes a long time. So skipping ahead. So the point is, you can do this with Jenkins. And if you also combine it with Artifactory and our library for that, we also have a cool feature, build information. And look at that, my last build actually worked. That's super exciting. So this is a Jenkins file.
We're not seeing that.
Thank you. This is a Jenkins file. How many of you are familiar with Jenkins? Most of you, that was pretty much expected. You guys know Jenkins files, pipelines? So all I'm doing in here is I'm running a Konan install, basically just like I did in my demo before. And then I'm running the 2-pass CMake build. And then I'm doing a quick test. And I'm promoting it. And then in this case, I'm also distributing it to the open source repository that owns it. And if we really did this right, you'll see that this last build took 7 minutes. And if everything in the build worked correctly, this next one should be a lot faster, but let's see if I actually got it all right. No, I did not. Okay. I was been playing around with my cache settings and managed to destroy my cache, and was trying to repopulate my cache and apparently did not succeed in doing so correctly. But you can see down here, if you go way down here, you can see that this build took 25 seconds, not 7 minutes. when I could actually pull everything out of my cache, from my cache, from my server. That's including download time from a server. Now, admittedly, the server is sitting right next to the build system, but nonetheless, that's a 7-minute build versus a 30-second build, and that's a big deal. Hopefully, you think so as well. So, yeah, that's Konan. Seems fair to pretty much wrap up. I can talk about binaries and binary package management pretty much all night, but an hour seems like enough for one night. I can come back and talk more maybe on some of this other stuff. As I said, if some of that other stuff I was talking about in the versioning and some of that stuff interests you and you want to talk more about it, let's get in touch. We are working on package management. They did a survey recently in the C++ community through Meeting CPP, and package management was listed as the biggest absence in C++ today. And so, setting Konan aside, even as a community, as a C++ community, this is something that we as a community want to address. Obviously, I think Konan is a big part of that solution. I don't think it's every part of that solution. There's a lot of things that will go into it before it gets to the end of that journey as a community. Understanding what various people's constraints and problems are with package management. How does this meet your needs? How does this not meet your needs? I want to hear those things. Before we move into the final Q&A, I want to go back to what I mentioned at the beginning about SwampUp. Because again, who doesn't want to go to Napa Valley, drink free wine, and talk about C++ or DevOps? Critical information, it's May 17th and 18th. There's a training day on the 16th. Among the things discussed on the training day is Konan. So this is a great way to get a class in Konan. Not from me, but from the actual founders of Konan. I will be there as well, but I'm not usually the main attraction in that respect. We're having some great keynote speakers that I think you can see over here from some great companies. Lots of breakout sessions, including an entire track dedicated to Konan and C++ development, as well as lots of cool tracks on other DevOps topics. And because you listened to an entire talk from me, you get a discount code, Konan_discount, if you decide you want to sign up. You guys at least don't have to get an airplane ticket to do this. So I encourage you to at least check out the agenda and think about it. Because that's what the people that paid for your pizza want me to say. No, actually, I have to say, I've been to every SwampUp, and while admittedly I'm biased because I'm a JFrog employee, it actually is a lot of fun. And we have a gala dinner at night, and I have to say that some of the most fascinating professional conversations I've ever had in my life were at that gala dinner. You're going to be thrown together with peers in the DevOps community, peers in the build community and developer community, and really get a chance to talk about genuine problems and how it advances, and it's pretty cool. So, thank you very much for listening. And do people have more questions? I know we answered a whole bunch of questions after the first demo, but do people have other questions? Yes.
One more. I just started looking at C++ unit test frameworks.
Mm-hmm.
There's one in particular that you recommend to work with the Konan CI workflow.
Not that I can really think of. They should all pretty much work. We have inside Konan itself, we have you can build a test function into the recipe, and it's recommended, but typically what that test function does is if you have a unit test framework, it calls that unit test framework correctly, right? And kicks off those pre-designed unit tests. If you don't have any sort of unit test framework, you can kind of use Konan to be that unit test framework, but that's, to be honest, a bit of a stopgap. It's designed, the test framework for Konan is designed to test package recipes more than it is to test packages themselves, right? So it's not really designed for a functional unit test. It's designed for, you know, did I successfully compile this object level testing? Yes.
So with all these packages that you successfully built them, what's the paradigm that JFrog espouses that the user's supposed to do, or how to interact with the loader? Are you going to turn out, I noticed earlier you standard out this human path, but I mean, you obviously handled the R path correctly, but that's the other stuff. So what are you intending the user to do? Is it just have a super long LD library path, or what's the user supposed to do with all these packages?
So no, it's a fair question. So I only did the first CMake pass. So if you're using CMake, right, for example, right, you basically just, you know, it loads the libraries into the places that CMake is looking for. It tells CMake, go look in these paths. And then you run the second path and do it. And basically you do the same thing with pretty much any other, you know, you use a make system or CMake, you use a build tool, and Konan tells the build tool, go look here for the binaries. And the build tool calls the linker accordingly.
Can that be a shared place?
So generally speaking,
or it's defined by the recipe, right?
It's defined by the recipe.
Yeah, so
generally speaking, it is shared, because it's generally speaking, it's the Konan local cache of that user. Okay. Is basically the answer to that question, is that generally speaking, that's where it goes, is the Konan local cache of that user with certain magic of that hash profile to say, right, because you may have a debug and a release build in the cache, right? To say, okay, go look at directory structures that look a little bit like this, basically.
So it's not creating a copy of the Boost library in each project.
No, it is not. It's storing it all in the local cache. There's a general rule. I mean, there are exceptions to that, but you know, the default behavior is it loads it into the user's local cache. You typically do want it to be the user's local cache. You know, if you want to share beyond users, generally speaking, that's not a great idea for a whole host of reasons. That's why you have server, basically, is to worry about the details of that one and manage the locks and concurrency and all those wonderful, lovely details. Does that answer your question?
Not really, but let's say you're working on 64-bit, and I know compatibility also works on 64. So can I say, okay, I can download this, something is available for 64, can I use compatibility?
So as a general rule, if you don't have the 64-bit, it'll go and rebuild it. If you told it that you wanted to target a 64-bit architecture, it'll go and rebuild it. Now, if you told it that I want to be in 32-bit compatibility mode, then it will happily go out and grab the 32-bit compatible binary and build that and use that. But if you're telling it, you know, my target architecture is x64, then if it doesn't see an x64 binary, it's going to download it and download the source and build it from source. Yes. 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 Absolutely. So it's a little bit more complex topic, so I didn't much talk about it, but I mentioned briefly, I think the build requires, and this allows you to download tool chains, which is very common in the cross-compiler or the device world. It's not super great if it also has to build the tool chain. You know, bootstrapping a tool chain is a bit much for Konan to handle. I've seen it done, but that usually requires a very complex and not very portable recipe to try to persuade it to properly bootstrap a tool chain, and we don't recommend it.
It is cross-compilation. It's outside of purview.
No, Konan does cross-compilation.
Okay, so it is
yes, you can set it. So for example, so what I can do is I can create a cross-compile profile. And you see here that I have a target of ARM v7, and I tell it, but my actual current build system is Linux x86-64, and it will load the correct cross-compiler accordingly, presuming it's available. So in this case, it's being told that it's supposed to look for, ARM Linux GCC and cross-compile accordingly. Yeah, no, any build chain, if you have the build chain to run the cross-compile, it can do it. It supports any compiler, any tool chain. In fact, I recently saw, we did a demo for a bunch of embedded boards, of downloading a binary package, basically, of the binary package that the manufacturer provides for its Bootstrap compiler, and cross-compiling with it. We're still playing with, we want to have some really good public demos of some of that stuff. And there's not a lot of public demos that involve cross-compilation to embedded systems. But that's actually something we're working on, of building more of those. Other questions? Okay. Well, thank you so much for your attention. This was a real pleasure. Hopefully I'll see some of you in Napa. And if not, hopefully I'll see some of you at a later date. And always feel free to reach out. You can close the stream now.